So occasionally, you might find yourself in a situation where somebody from the outside world needs to get in. And there's two real ways to approach that. One would be somebody who's part of the company, like maybe this guy here, and he needs to access resources inside the network here. So maybe the file server or some of these clients or something like that. So what we could do is we would set up this thing called a RAS server. RAS, Remote Access Service. RAS supports something called a VPN, Virtual Private Network. VPNs would allow people to remotely connect in, securely encrypted to that RAS server, and then they could access things like the file server, things like that. And so that's all wonderful and great. The one thing, though, about VPN users is they have to authenticate. They have to prove who they are. What about this situation, though? What if your company wanted to host a web server? All right. They want to host a web server, like this little box that I'm drawing here, and they need to make that web server available to people anonymously. In other words, people that are not part of our company. Well, you run into a slight issue there. The issue you run into is where do you put this web server? If you put this web server here on the internal network with your stuff, you're basically letting someone who is not part of your company, you're letting someone who is not part of your company access that web server. If this person right here is not an employee, he is just an anonymous person on the internet, we don't want that person being able to gain access to this web server. Hackers can do this thing called pivoting. Pivoting is where a hacker gains control over this server and then they're able to actually pivot to other servers. So that would be a bad thing. We don't want that. So one thing we could do is we could store this web server on the outside. We could store it out here outside our firewall. Of course, the problem you run into there is you've not left this server any protection. Basically, the server's outside your firewall, and at that point, it's completely exposed to things on the internet. So the rule of thumb, the general rule of thumb everybody went with is they would get another firewall. So you'd get a second firewall. I'm just going to copy this guy right here. And we would put that firewall right here. And that is called a DMZ, a demilitarized zone, also known as a perimeter network. And what you would then do is you would put rules in place on these firewalls so that people out here could get in through this firewall and access this server, but you had this firewall acting as an additional layer of protection to stop things from getting in from that outside world to the inside world. Okay, so this was a pretty traditional approach. This is the way we've done things now for years. We've centrally managed things through Active Directory domains in the Microsoft world, and it's a great solution and it's worked fine. Another thing that we've had for years is the concept of having internal servers that do different jobs. For example, we might have an Exchange server, which is an email server that Microsoft supports. It's their email product, actually. And we'd have an on-premise email server, and people could check their email and all of that from the outside world to the inside world. There were some things you had to implement to do that. Another thing we had was SQL Server. SQL is Microsoft's database product. So we'd have SQL servers handling databases for us. We would have something called SharePoint, which allows us to set up some different types of sites that employees can use for things. And we could do Skype for Business, all of these different things. Skype for Business being Microsoft's sort of voice over IP product for the longest time. And we would have, I'll just put Skype for B to represent that. We would have all of these servers in our internal environment. And guys, this is the traditional approach, the way that we've done things now for decades, for years. This is the way things have been done. So now what I want to talk about is moving into the future. As time went on, as we moved into the year 2000s, we moved in the early 2000s, there was a concept known as virtualization. Now I want to warn you guys that the concept of virtualization is not a new concept. A lot of people think it is. It's actually not. The term virtualization has been around since the 1970s. There actually was a Unix-based operating system that had a thing called a hypervisor that could do virtualization. It's just virtualization really didn't blossom until the early 2000s when a company called VMware discovered and created some really awesome features that could allow companies to take advantage of something called elasticity. So I want to talk about that for a minute, the concept of virtualization. So what I'm going to do is I'm going to move these servers over here for just a minute. We're going to move them out of the way. And what happened was, with the concept of this company called VMware, they discovered that instead of us having to buy like 4 different servers, they created a way to where we could take one physical server with a lot of power, a lot of performance, CPU, memory, storage, and put all of that on this one server. And this server is known as a hypervisor. In Microsoft's world, which is the world we're living in right now, it's called Hyper-V. Okay, so there's VMware, which is third party. There's Microsoft Hyper-V, which Hyper-V is sort of what we learn about in this course. So Hyper-V, hyper-virtualization, allows us to virtualize these servers. So think about it. If you can emulate hardware, okay, CPU, memory, storage, networking, then you could technically set up operating systems that run on that emulated hardware. Well, those are called guest operating systems. These right here are virtual machines running guest operating systems. Of course, the scary thing about that, the thing a lot of people freak out about, is they're like, well, if one of those servers fails, okay, if the Hyper-V server fails, I should say, if it fails, you lose all access to all your servers. Well, see, that's the beauty of virtualization. It's very easy for us actually to just get 2 servers, okay, and we can do something called clustering, where we can connect these together and we have a duplicate. Now, if one server fails, we still have that other server. In fact, these 2 servers can actually even be in 2 completely different offices if we want. Okay, so I could have them in 2 different branch offices if I wanted. So notice, this is going to save us a lot of money on hardware and all of that. Here's the other beautiful thing about virtualization that they created. It's called elasticity. Elasticity involves the ability for your virtual machines to be able to request more resources when other virtual machines aren't using them. So, for example, if the Exchange server is using, let's say, 20 gigs of RAM, okay, and the SQL server needs 30 gigs of RAM, and the Exchange server currently is not needing all that extra RAM, it can release that memory that it's not using, and the SQL server can use it, can take advantage of it. And then if the SQL server no longer needs that memory, it can release that memory and the Exchange server can get it. And this is what elasticity is all about, okay? And what you're going to find is this is the forerunner of cloud computing.